Hello, welcome to our video for uh, presentation for cost project management. We are from Group A, and before we begin with our presentation, I would like to introduce myself. My name is Otnil Cliff, and for the others member, Anding, Adib, Hisham, and also Sarvin. Okay, so for the project overview, as we know that the Smart Waste project was initiated to improve efficiency in DBKU waste management operations. Traditional static collection schedule causes unnecessary fuel consumption, labor costs, and vehicle wear, while failing to prevent bin overflow in high-density areas. To address this, Red Dragon Tech (RDT) proposed an IoT-based, demand-driven collection system using ultrasonic sensor, edge gateway, and a cloud analytic dashboard. As the project transitioned from planning to execution and control, external economic pressure and internal strategic realignments at DBKU required revision to the project's scope, time, and cost constraints. For the client's new requirement, after our initial plan due to external economic pressure and internal strategic realignments, our client Dewan Bandaraya Kuching Utara DBKU has requested a 10% schedule cut and a 20% budget reduction. Here is how we adapted. For the first one, schedule compression. We reduced the original project timeline by 10% to demonstrate results before the upcoming municipal budget review. For the second one is budget rationalization. We cut the approved project budget by 20%, reflecting broad fiscal tightening in the technology procurement divisions. Next slide, I will pass to the next presenter, which is Aning.
All right, thank you, Otnil. So, part one, strategic project revisions. Next, schedule optimizations. The original project schedule had a total duration of 135 days, approximately to 27 weeks. The directive require a 10% reduction, which equal to a target reduction of 13 days. The new target duration is set at 122 days. The primary schedule compression techniques we're using. So first one is fast tracking. Tasks originally planned sequentially were executed in parallel. Second, trashing. Additional skill resource was assigned to critical path tasks, especially in the build phase to shorten the schedules with increase offset by budget optimization. Optimization. Okay, next. So here we are using a Microsoft project to make changes, and here we show a Gantt chart in tracking mode. So black bar color shows the original timeline and red bar color shows the new timeline. Alright, next. Alright, I will pass to Hisham.
Alright, thank you, Anding. So, let me talk about the budget change for our smart waste project. The client asked us to cut the budget by 20%, so we had to reduce our original budget from 197,000 to 157,600 ringgit. The reduction of around 39,400 ringgit. As you can see in this table, we reduced both human resource and procurement costs. HR went from 121,000 to 97,000, and the procurement dropped from 76,000 to about 61,000 ringgit. Now let me show you how we did it. Next. Okay, so here is the breakdown of what we cut. For human resource, we made some small change. We reduced the project timeline from 6 months to 5 months. We also use cross-training so team member can handle multiple roles. And we brought in part-time consultants instead of hiring full-time for everything. For procurements, we reduced the IoT sensor from 190 bins down to 150 bins, and we focus on high priority zones like the city center. We also cut the gateway device from 4 to 3 units, negotiate better price with vendor, and maximize the WS free tier to save on cloud costs. So basically, we cutting the cost but keeping the important stuff. Next. Now, you might be wondering what the impact of this cut. Well, audience coverage dropped from 38% to 30%, and the project duration is now 5 months instead of 6. We will use 3 gateway devices instead of 4. Our MOV achievement will be around 85 to 90% instead of 95%, and the trip reduction will be 20% instead of 25%. So yes, there are some impact, but still good. To manage this, we doing daily stand up using Moscow prior- prioritization to focus on the must have and deploying in high impact zone pros. We also have phase plan to expand later using the saving we'll get from operation. So the revised budget for budget 157 600 ringgit still keep the project viable, and we can achieve 85 to 90% of our original targets. Next. Okay, so finally, let me talk about the risk. With the budget and schedule cut, we identify risk at each phase of the project. In the initiate phase, there's risk that MOV target might not be achievable with 20% less funding. Our strategy is to accept that we might need to adjust our scope. In the plan phase, we might face budget overrun, so we reduce the IoT sensor and gateway to bring costs under 160,000 ringgit. During execute, there is risk of sensor calibration failure. We do rigorous prototyping and testing before deployment. In the control phase, there a risk critical path delay. DPM will monitor weekly and use parallel processing to recover any delay. And the last one is the close phase. There is risk of low user adoption by DBKU staff. So we will deliver proper training and documentation before final handover. This is it for the budget section. I'm going to pass for the next presenter.
For the part 2, implementation and project closure plan. Next. So for the implementation and closure, first is the conversion strategy. The successful implementation of the smart waste system requires a carefully planned conversion strategy to move from the current DBKU manual waste collection system to a new automated system using IoT. DBKU currently operates a manual waste collection system with the following features. First, fixed route scheduling with fixed collection times, no real-time visibility of bin fill levels, limited data for waste collection route optimization, high fuel consumption due to inefficient waste collection routing, and frequent incidents of bin overflow. Next, I pass to the next presenter, Savin.
Thanks, Adib. Conversion strategy evaluation. Three conversion strategies. Justification. For the smart waste system, which is IoT-based and affects municipal waste collection, a critical public service, a phased approach is recommended because first is risk management. Failure in one phase, example sensor deployment in one zone, does not crash the entire system. Issues can be contained and resolved before wider rollout. Second is user adaptation. DBKU staff and citizens can gradually adapt to the new system. Training can be conducted in stages. Third is resource efficiency. Team can focus on one module location at a time, less strain on budget and personnel compared to parallel run. Fourth is alignment with pilot nature. The project is already a 6-month pilot. Phase rollout fits the pilot, then scale approach. Why not direct cut over? Too risky for a public service system. Failure could disrupt waste collection citywide. Why not parallel? Too costly and complex for IoT sensor networks. Running two waste collection systems simultaneously is impractical. Implementation plan for phase conversion. Phase 1. Module location is pilot zone, example CBD. Duration is 1 month. Key activities is deploy sensors, test dashboard, and train staff. Phase 2. Module location is zone 2 and 3. Duration is 2 months. Key activities is expand sensor coverage and optimize routes. Phase 3. Module location is full city rollout. Duration is 3 months. Key activities is system-wide deployment and final training. Phase 4. Module location is post-implementation review. Duration is 1 month. Key activities is evaluate MOV, collect feedback, and finalize. Project closure checklist. The project closure checklist ensures the smart waste project is formally completed and handed over to DBKU. It confirms deliverable completion, client acceptance, documentation, financial closure, training, and knowledge transfer. The checklist also supports a smooth transition to operations, records lessons learned, releases resources, and officially closes the project. Next, I pass back to Anding for the final part.
All right, thank you, Shavin. Now we on MOV evaluation discussion. The measurable organizational value (MOV) for the smart waste system focus on waste management from a static schedule to a data-driven, dynamic approach. Success is measured by operational savings and citizen satisfactions. Evaluation frameworks, system logging, utilizing automated system logs to track mean time to respond for overflowing bins. Next, operation audit, comparing monthly fuel receipt and trips logs against the baseline of 1,000 liter and 15 trips per day. And lastly, public survey, implementing digital survey to reach the target of over 85% citizen certifications. Alright, next. So this is our MOV evaluation summary table. So firstly, area of impact operational project goals MOVE, efficiency improvement. So metric or indicator, which is average collection trips or days. Baseline data 15 trips and target 6 months, which is we reduce by 25%, which is 11 trips. Next one, financial project goals, cost or fuel reduction. So our indicator, monthly fuel consumption, baseline data 1,000 liter. So target for 6 months, we will reduce by 20%, equal to um, equal to 800 liter. So next area of impact customer project goals, citizen certifications, indicator public certifications score, baseline data 65%. So our target 6 months is equal or both equal or bigger than 85%. So next area of impact service responsiveness, indicator overflow response time. So baseline data 12 hour. So we try to target for 6 months is 4 hours. Next area of impact reliability, project goal system uptime, indicator dashboard uptime. So baseline data is not available. Our target for 6 months is equal or bigger than 98%. And lastly, environment project goals, emission reduction. So indicator will be carbon carbon dioxide CO2 emission tons or month. So our baseline data is 3.5 tons. So target for in 6 months is 6.8 tons. All right, move to the next part. All right, that's all for our presentation video. Thank you for watching.